In this video, I'm going to be answering which isomer, either the cis or trans, is most stable of this molecule right here, which is 1-tert-butyl 4-methylcyclohexane. So to go about answering this, you just start by drawing the chair conformations for both the cis and trans, and then just look for things that would indicate stability. So I'm going to start that, simple chair, and I'm just going to choose this to be carbon 1 right here. And this is going to be the cis isomer, so they're both going to be in the up position for this one. Now I'm going to count how many carbons away this methyl group is. 1, 2, 3, 4. 1, 2, 3, 4. And this one's also going to be in the up position because this is cis. So it's going to be up like this because the axial position is down, and that would not be what we want. And we also have to draw the flipped chair because that is also contributing to the structure. So in order to draw flipped chairs, you're pretty much just drawing a mirror image of a normal chair, which is kind of annoying, but with a little bit of practice I'm sure you can figure it out. I guess that's okay. And for flipped rings, any substituent that is on this upward carbon 1 becomes, if it's up right here, it stays up, except it goes from an axial to an equatorial, and it's like that with all of them. And this carbon is the same as this carbon. So once you get track of that, it's pretty easy to do these problems. So your tert-butyl is right here, and then also 1, 2, 3, 4, 1, 2, 3, 4. So your methyl is going to be here, and because it's an up here, it's also going to be an up here, and just changes from an equatorial up to an axial up. And you can tell just from looking at that this one's going to be contributing more to the structure of this. So I guess I'll draw it like this, because the larger substituent is in the equatorial position, which you want because it has less diaxial strain. And now I'm going to draw the trans conformation. So for the trans, we're going to have tert-butyl in the upward position, except now we're going to have this guy in the downward position because we're trans, and down on this carbon is a downward axial position. And again, we have to draw the flipped chair, unfortunately. That's pretty good. Okay, so tert-butyl is here, and again it is equatorial. And again, we have to come to this guy, except now it's going to be down, so it's going to be a downward equatorial methyl. So you can see that this one's going to be especially stable because both substituents are in equatorial positioning instead of axial, so it's not going to have much diaxial strain. And because of that, you can see that this guy is definitely the most stable of all of these, and because of that, the trans isomer is going to be the most stable.